Hello, everybody, for the session of APQP and Control Plan. We'll give it just maybe another minute or so, and then we can start. So let's just wait maybe one more minute so people can get logged in, and then I can start. Okay, so I think we can start off. So thank you everyone again for joining this session about APQP and Control Plan. And I couldn't think of a better person to present this as Milo Budar, with his long-term experience in the field of automotive and automotive supplier management in general, and of course in the APQP and Control Plan. So first of all, thank you very much, Milo, for your presentation today. I am already looking forward to get your insights and point of view on this topic. And again, if anybody has a questions, we have planned 20 to 30 minutes question and answers after this presentation. You can put your comments, questions, or anything in chat, and we can talk about it afterwards. So Milo, again, thank you very much, and I would hand over to you, and looking forward to hear from you about APQP and Control Plan.
Okay, thank you, Andre. First of all, can everybody hear me okay?
Yes.
Yes.
Okay, great. So thank you for the opportunity to present the topic today. So since Andre already introduced me, I would like to introduce myself briefly. So my name is Milo Berdar. Some of you online might or might not know me. So for the past 46 years, I was working at the Robert Bosch, part of in different countries, in different disciplines. And just a brief background. I mean, the presentation is not about me, but just a brief background that you know who am I and what I'm doing. So I graduated in 1982 from Berufsakademie in Stuttgart. So that means I started with Bosch in 1979 as a student, and then worked for several years as a design engineer for power generators in a Bosch division that's called Eisenmann. Bosch does not have this division anymore. They sold it at one point in time. Then I switched to, in the late 80s, when the ABS systems took off, the anti-lock brake systems, I switched to ABS as a design engineer for the wheel speed sensors, and also with the wheel speed sensors, I then moved to US to the plant in Anderson, where we manufactured the wheel speed sensors. And in the process, I also took over the responsibility as a design engineer for electromagnetic relay that was also moved to Anderson, South Carolina. And so I worked there until 95. In 95, I moved to the plant in Cardiff in Great Britain, also in a function of design engineers for alternators. And in 97, when Bosch bought in USA the Allied Signal, the braking division of Allied Signal, I moved to the plant Gallatin, that's close to Nashville in Tennessee, and worked there in a function of a technical manager, of responsible for the plant maintenance and so on. Yeah, and in 2001, I moved to back to Germany, and worked as an application for diesel systems, and worked there for 2 years. And then I switched into the braking division and developed the product engineering process. That is the PEP, product engineering process. It's known under different name, but it's essentially the development process for products that go from the initial concept into series. Then in 2005, I decided to move back to US and worked there since 2005 in supplier quality, again in different functions. And to make a long story short, in between, I was the manager for the VDA 6.3 audits for US and Mexico. And afterwards, I took over the function of the direct supplier quality responsibility for gasoline system, transmission controls, and so on. Yeah. Okay, just a second. It seems we have some. Okay. So I apologize. It seems I did not turn on the camera. So this is me. Hello. And in about a month ago, I retired from Bosch and have been working since then as an independent consultant for the Metis company, which is really led by my daughter, and we work a lot with the AIAG. So that's just briefly introduction of who am I and my background. So again, apologies here. So today I want to talk about the APQP, and you can see as a table of content. So first of all, what is APQP? Then for those of you who are not so familiar with the AIAG APQP, but are familiar with VDA, just give you a brief outlook and a brief comparison. How does APQP compare for AIAG versus VDA? Then I want to talk about the core tools, about the structure of the APQP, and also a little bit about the history of APQP. Then specific portion of the APQP is the control plan, because APQP is more than just control plan, but control plan kind of brings everything together. So I want to put focus a little bit on the control plan. What is it? What are the goals and so on? What are the chapters? What are the key aspects? Also, then back to APQP, to the AIAG APQP. In the structure, there are quite a few appendices, and I want to take a brief tour through the appendices, what they are, how do they support your business, and so on. Yeah. Summary, and then the QA, question and answer, as Andre already indicated. So without further ado, what is APQP? Yeah. APQP stands for Advanced Product Quality Planning. So that is really a product-oriented quality planning process that supports development of products and series to meet the customer requirements. And it's really a system, or you can say a structure, that covers the entire chain from the inception, from the product, from the idea of the product, from concept of the product to introduction into series production, to go to ramp up into series production and so on. Yeah, and if the APQP process, it's applied consistently, or as it's called in German, consequently. Yeah, that will assure that on one side there you have a reliable process. Reliable process is an efficient process, and efficient process makes good products. And if you do have an efficient and good product, then that will result in customer satisfaction. So in essence, it's a little bit of what is the famous Toyota philosophy, that a good process will give you a good product. Yeah, so that's pretty much the thinking behind the APQP process. So as I mentioned before, some of you might or might not be familiar with the AIAG process. but might be familiar with the VDA process. So in VDA, there is the product that is called MLA, the Maturity Level Assessment, which is similar but different than AIAG APQP, because the AIAG APQP has the focus on enhanced product quality planning and also provides a framework for the product development process. Contrary to that, MLA is more focused on the maturity of the product and process, and also on interactions between the customer and the supplier. And also the methodology, it's a bit different one. The VDA MLA defines maturity levels, and VDA has kind of maturity level, but these are the quality gates which are then evaluated throughout the project. So the goal of both, they both aim to assure consistent processes and also consistent product quality. But VDA puts more focus and specific emphasis on the maturity level and on processes throughout the product chain. So the next point is a little bit of a history of APQP. So the APQP, AIAG APQP was introduced in 1994 with the first edition, and it was revised relatively quickly a year later with the second edition, which really introduced some, let's say, minor improvements, minor changes. And then there was the first major revision was in 2008, and which was introduced in a second edition. And this was along the line of the AIAG philosophy to say, hey, we have a process and we want to introduce that process in a way that it's continuously improved. So these changes, these were gradual small changes to the APQP methodology, to the APQP documentation, and so on. Yeah. The intention of this seminar is not to go into this detail. So just for you to take with you, these were small incremental changes over the years for the AIAG. And then in 2024, there was a major change to the APQP, and the major change was that it was recognized that the control plan, it's really such a central document, central process of the APQP, that it made it worthwhile to kind of take it out of the APQP and make its own document out of it. And that was the change that was introduced in 2024. Again, there are specific seminars on explaining what are the new changes and so on. That's not the focus here today to talk about changes of the second to the third edition. So, what is the core of the APQP? So, this is defined very well in the chart here. So, the APQP process consists of several defined steps, which start at the concept phase and goes all the way into introduction of the series production. And throughout the process, there are quality gates. These are these diamonds. I will talk about them in a moment. Yeah. So at each step of the process, the quality level of each process, it's reviewed, it's documented, and it's checked. Does it meet the maturity that allows it to go to the next step? So the idea here is, again, if the product does not have a certain maturity, product, it also can be a process, product can also be either a physical process, a product, or a service. If it does not have a certain maturity level, then it's really not a good idea to continue to go to the next process step, carrying all the immature issues from the previous level, from the previous step, before they are resolved. So these are these quality gates. And the steps, they are self-explanatory. So there is the planning step. So you have initially a concept. Yeah. Then you go through the planning phase and you evaluate, am I now ready to take this planning phase into the product design and development? Yeah. In parallel to it, and you see that it's not beginning of the phase, stop, beginning of the next phase, stop, beginning of the next step. There is quite a bit of overlap of the phases in between. Yeah. So this is very natural. And this is also helps the CIP process, the continuous improvement process, that you say, if I'm in a step of product design and development, then I go into process design and development. And there is a continuous feedback loop. You see here in the bottom, there is the loop of feedback, assessment, and corrective actions. That is there from the very beginning to the end of production. So the idea and the intention here is so that we don't say, well, we have done something, we close it, we assume everything is correct, let's move on to the next step. No, we learn something in each step, and this is continuous feedback loop that goes between the individual steps, between the individual phases. After the process design and development, then comes the product and process validation. So the product needs to meet the customer requirements. And in order to prove that the product meets the customer requirements, it has to go through a vigorous series of tests in order to meet those requirements. And when we say customer requirements, these are not just the customer requirements of the customer who is the initial customer. So let's say the OEM, where the tier one sell their products. This is also the requirements of the customer who buys the car. Yeah. In a way, also our government, it's a customer, and the government puts out certain requirements that are called laws and regulations that also need to be met. And then one of the customers, it's also, as they say so nicely, Mother Nature. Yeah. So there are certain things that, particularly when we're talking physical products, there are certain physical limits that certain materials can meet. Yeah. And again, in a process, you might find out, yes, I have foreseen a material for my product, and now I test it, and then I find out, well, either design of that material, it's not good, or the material I have chosen is not good. Yeah. So I go back and say, okay, I have to use a different material. So that's what it's really meant here. These three things go kind of hand in hand. Yeah. And then at one point in time, because we don't do all these exercises just to get nice work to fulfill the day. Yeah, we go into series production, and then we have to evaluate: am I ready for the series production? Yeah, and once I'm ready for the series production, then I ramp down my planning, my development, my testing phase, and I go into ramp up and series production. And again, also here, I have a constant and continuous feedback loop of feedback, assessment, and corrective actions for the product and services. So how do we do that? So it was already mentioned several times, and Andreas also addressed this in his morning session, talking about different structures and different quality structures. Yeah. So there is so the core tools and the structure of the APQP is shown here in, let's say, in the major elements. So the APQP is kind of the overriding thing. So there are two, strictly speaking, two different we mean two different things when we mean APQP. On one side, APQP is the entire process of planning, of quality planning, of introduction. And then APQP, it's also the manual that is that documents most of these items. So when we talk about APQP, we have to make sure, are we talking about the entire process, the framework, or are we talking specifically about the one that it's defined in the manual? Yeah, so they kind of go hand in hand, but they are not necessarily identical. Because part of APQP, it's also FMEA, the failure mode and effect analysis, which is, again, its own tool in itself, has also its own requirements, its own manual that have been standardized between AIAG and VDA recently. Yeah. And the output of the FMEA is the input into the control plan. Yeah. And as I mentioned, control plan is such an central point in the whole quality planning that now AIG has decided to make an individual document out of it. Yeah. And then the next document, which is also a AIG document, is the MSA, the measurement system analysis, which is important. So following the MSA, that means that you have to prove that your measurement system that you are using, they have to be process capable. They have to be measured. They have to be capable to do the correct measurements. Because if you cannot trust your measurements, if you cannot trust your data, then anything that you do does not make sense. Yeah. So things which I say here, they kind of go without saying. Yeah, this is like breathing. Nobody tells you you have to breathe correctly in order to survive. Yeah, so MSA is a big item. So if you can, again, I know I'm repeating myself, but if you cannot trust your measurement systems, yeah, how can you trust the data which come out of the measurement system? Yeah. Then in a series production, where needed, you have to introduce the SPC, the statistic process control. It does not mean that you have to have SPC on a mandatory base for every single critical dimension. It's where needed, yeah. But if needed, there are certain rules and regulations how to do the SPC correctly, yeah. And all these, it's in a preparation to the final step, which is you need to get the customer approval to be able to go into series production. And this customer approval in AIG world is called PPAP. The PPAP stands for Product Part Approval Process. And also PPAP has its own manual. The current version is the edition 4 from, if I'm not mistaken, 1994. I'm just pulling from my memory. Sorry for that. Yeah. And the document within the PPAP that it's signed, it's called the PSW, the Product Sample Warrant. Yeah. So the counterpart to PPAP is the PPAP manual is the VDA2, and the counterpart to the PSW in AIAG is the PPA cover sheet that the VDA is utilizing. So there are a lot of parallels between the VDA and AIAG, and also the structure is fairly similar. So, as I mentioned before, in 2024, AIAG decided to do the control plan as an individual document. And so currently the valid documents are the APQP third revision, and in the control plan is in the first edition. So these are the currently valid documents for both of these documentation. So the structure of the APQP and of the control plan. So when you look into the APQP document, there used to be six different chapters. So this is the chapter, let's call it 0, yeah. It's the general introduction. Then chapter 1 is the plan and define program. Chapter 2 is product design and development. Chapter 3 is process design and development. Chapter 4 is product and process validation. And chapter 5, it's the feedback assessment and corrective actions. And just to show briefly, so this is the description of these individual chapters, which are shown in the timing chart. So individual chapters define the requirement and actions for each one of these individual steps. And the chapter 6 used to be the control plan. And as I mentioned before, over years, it showed that the control plan is, first of all, it's its own animal. And second, it has so many different things and it pulls so many different strings together that it was necessary to make its own document. And so the first edition of the control plan has also 4 chapters, respectively 5 with the appendices. And so chapter 1 is the control plan development and guidelines. Chapter 2 is control plan development. Chapter 3 is the control plan phases. Chapter 4 is how do you use effectively the control plan description and the guideline. And chapter 5 is appendices A through F. And these are the different examples and also checklist, glossary, and so on. So this is really, to use Andreas's exception, that's where the action happens. This is the engine of your advanced quality planning. So why did AIAG do that, and what are the goals of the APQP and control plan? Yeah. So the first goal is in the so there are 3 big phases that are used in the development and supplying and distribution of a product. Phase 1 is in the project management. Phase 2 is the sourcing of the product. And then phase 3 is there were certain definitions that were taken from before, expanded, modified, and fine-tuned. Yeah. So the goal of the program and project management is to have a good methodology for risk management and mitigation. Second is to have the quality gate for each project phase. So that's what I already mentioned before, that before you go into the next phase, you have to make sure that your current phase has met the goals which are defined and also has met them in a satisfactory way. Yeah. And then Andreas also mentioned in the morning session that you cannot have processes without the KPIs, because the KPIs tell you how well are you doing with your process. And so what APQP and control plan, they also define the KPIs which are related to the APQP process. Again, I don't want to go here into turtle diagram and so on. Andreas explained a lot of these in the morning session. Yeah, but this is really where it tags on the whole thing. So it's the same methodology applied for the control plan. Then when you go to sourcing of your components, there is really increased focus on individual sourcing phases. So there are also phases defined for the sourcing of each component. Then you have a multitude of checklists for assessing and mitigating risks in all sourcing phases. And also you have the quality gates, which are used throughout the supply chain. So here's the same philosophy and methodology applied. So you have the quality reviews within the individual project phases, and you have the project reviews within the individual purchasing supply chain phases. And then, as I mentioned, you have the lessons learned that were learned over the last couple of years from having worked with the APQP, is there were incremental changes done to the change management during the APQP. There were also, it was recognized that you have to do fine-tuning of the capacity planning using the OEE, the original equipment efficiency. So the OEE is the uptime of your machine essentially, yeah. And high percentage of OEE means your machines are working efficiently. You have little scrap, and efficient machine and little scrap means that you will keep your cost down and you will keep your quality up. Then traceability. This is also one big issue that has come up from the OEMs in recent years. Yeah. And this is mostly driven by the fact that when you have a defect out in the field, yeah, and particularly nobody likes the R word, the recalls, yeah, that's why OEMs usually call it field action. But if everything fails and if you get to that point, yeah, then you want to be able to trace your components which were the reason for the let's call it for the field action, to trace them back to the source, and you really want to limit the amount of the parts that you have to replace or that you have to check, so that your recalls are limited to a, let's say, reasonable amount of components. And you can only do that if you can reliably trace back from which production batch, from which production lot, from which production time frame are my defective parts. And so the traceability concept has become a very, very significant portion of the planning process, because it's again, the fewer cars you have to repair in a case of a field action, the fewer is the overall cost that occurs. Yeah. And then also here, last but not least, is the prevention and error avoidance. Yeah, that kind of goes without saying that the best way to fix an error is to make sure that it never happens. Yeah. So if you have actions in place that help you prevent occurrence of errors, then you will also make sure that you will be able to keep a high quality level, and high quality level also means high level of customer satisfaction. So in order to achieve that, the control plan has description and definition that helps the companies to guide the company through the process of quality planning. And so the chapters in control plan, number one is introduction. So that means it's the correlation to APQP processes, and its emphasis really on the living document. Living document really means, if you remember, the bottom part of the APQP timeline was continuous feedback and continuous improvement. Yeah. So it does not mean that you document your control plan once and it's documented forever. No, it's a living document. As you learn, as you go along, you put the improvements forward and you introduce the improvements as they happen. You don't just improve them at that one theoretical point in the future. Then the chapter 1 defines the control plan requirements and guidelines, which means these are clear requirements for key issues such as common vulnerabilities, which means lessons learned. Where do we know that we have our weaknesses? And if we know where we have our weaknesses, then we should be also able to say, well, we know where the weaknesses are. Now let's put the corrective or preventive actions in place. Yeah. So that's what it's meant with common vulnerabilities. Where are we exposed? Yeah. Then also one big point is different customers, they have different requirements, different expectations. Yeah. And the chapter 1 tries to harmonize these customer specifications, not necessarily to go back to the customer and say, hey, dear customer, you really have to all have the same specification. No. What it's meant here is there a different customer expectation, different customer specification. How do we bring them all to, let's say, to a reasonable level of control? Yeah. The chapter 2 is the development of the control plan. So these are then guidelines with the focus on the process-oriented approach. Again, process-oriented without going into the whole definition of it, but you have certain inputs, you have certain process definitions, you have certain outputs, you have certain KPIs and so on. Yeah. Then also here, there are different phases of the control plan. And it defines the importance of each phase, harmonize customer specifications for a safe start of series production, and so on. Yeah. And then chapter 4 is about the effective use of control plans, which means maximizing the effectiveness of control plans in a context of holistic quality management. So these are the chapters of the control plan. Among these, what are the key aspects? Why are we doing all that? Yeah, why all that meaning? Why is there a control plan process in place? Yeah. So the main aspects are the special characteristics. So each customer has defined certain certain dimensions, certain characteristics as their key or critical characteristics. And now if you look to customers like Ford, Stellantis, whatever, yeah, each one of them has a little bit different way to define, okay, these are my special characteristics, these are my important characteristics, yeah. And so the important thing is to provide a correlation matrix to say, okay, yes, our organization understands what are the customer, what is important for the customer, what characteristics did they define as a key or critical, and also why. Yeah. And so we use these metrics to then deploy these identification of the critical or key characteristics through our process documentation. So that means these key characteristics, they also need to be identified in our FMEAs. They also have to be identified in control plan, and they also have to be process capable. Yeah. So it does not mean that we stop there and say, hey, we look just what is important for the customer, but in our development, so we get the customer specifications, and then for our internal. So if we are now tier 1, yeah, and we say, well, in order to meet the customer specification, we have to produce the parts a certain way, we have to assemble them a certain way, we want our suppliers to produce and manufacture them in certain ways. So we, as the organization, we also define certain important or critical characteristics or special characteristics. So these terms, some companies say they're interchangeable, some companies say they're different, but essentially they all describe the same thing. So these are special characteristics which are special for whatever reason. Yeah. And so again, when somebody talks about special characteristics, when somebody talks about key characteristics, when somebody talks about the important characteristics, yeah, to be honest, in a practical application, they all mean the same thing. Yeah. So these are the characteristics that need a special focus in design, documentation, and manufacturing, and in control. The next aspect is the lead and process times. Yeah. So we need to establish a process to identify and modify the process time. So that means we need KPIs and OEEs. And also, how do we communicate this with the customer? Yeah. Because the customer gives us prediction, gives us certain volumes. Yeah. So the customer volumes, they dictate the takt time that we have to deliver the correct amount of components to the customer. And in order to meet to meet that requirement, then we have to kind of roll it back to our own production and into the supply chain, so that we say we have to make sure that we have sufficient capacity of our machinery and equipment, but also we have to make sure that the capacity, that the machinery and equipment has sufficient quality level and sufficient uptime, so that we don't have to duplicate and triplicate it if not necessary. Because each machine that we have to duplicate because of low OEE and low output does two things. First of all, it creates high level of scrap, and second, it reduces our output. Reduced output, again, means reduced deliveries. The next key aspect is, as I already mentioned, is carrying this whole methodology into the supply chain. And in order to do our own control plan, we also have to align our control plan with the supply chain control plans if required. Yeah, because we really don't want to have a mismatch in information that we get from supplier to the information that we have in our own organization. So these two things, they need to be aligned. Then a huge aspect of delivering, of ramping a product, is the so-called safe launch concept. And there are, again, different names for it. Some call it safe launch concept, some call it early production containment, some call it in GM time, I don't know if they still call it GP12. So different companies call it different names. But what is behind it is that we say during the ramp-up phase, in the start of production and during the ramp-up phase, we have to make sure that we put increased quality checks, increased quality gates, increased quality controls, so that when we deliver the product from the sub-supplier to supplier, from the supplier to our organization, when we deliver our products to the customer, that we have to make sure that the products are manufactured correctly, that they are checked correctly, that they are packaged correctly, and that they are delivered correctly. So that's what's behind the safe launch. Yeah. And then there are some additional control plan aspects. One of them is the so-called reverse FMEA. So reverse FMEA is essentially nothing else but after the manufacturing, after the production process is established, to have a cross-functional team that uses the documented FMEA and walks the process. It's also sometimes called cross-functional line walk. Walks the process and see, I have defined, our organization has defined the FMEA. Yeah. Now, is that FMEA effective? Are the controls which are put in place, are they in place? Are they effective? Are they in the right place? Do they work? Yeah. Did we miss something? Yeah. So that is the idea behind the reverse FMEA. Yeah. Then we have also the layout process audit to verify the control plan on a regular basis. And this is also something that is sometimes misunderstood. So the layout process audit is not repeating the process or repeated the control plan again. No, the layout process audit, if you dig into it, this is when there are specific, just very specific controls put in place that are verified. For example, is the operator doing something that the control plans tell him to do? Does the essence of it, it's also to say, does the supervisor check that the operator is doing what they'll do? Yeah, it's also for the director, for the manager of the whole manufacturing chain to check in regular time frame. Do my supervisor make sure that my operators are doing what they're doing, and so on? Yeah. Again, the intention here is not to do a training on the layout process audit, but that's what's behind it. There's actually a specific CQI on the layout process audit as well. Yeah. Then if I have products which are variations of each other, So then there is established the so-called family FMEA and family control plan. Yeah. So very simple example. If I have screws, which are all the same, M8 screws, but one is 15 millimeters, the other one is 20, the third one is 25 long. Yeah. I don't need a specific FMEA for each one. I establish a so-called family FMEA and family control plan, and then just have the very specific controls if and where needed for those specific screws with the different length. Again, it's a very simple example. Yeah. Then there is the monitoring of high-risk storage and transport processes. Yeah. This is also one thing that out of experience, as I said, I've been now, or I've worked in automotive industry for almost half a century. Yeah. And one thing that was very often underestimated is the importance of suitable packaging for my components and products. Yeah. And the farther up you go in the value stream is the more issues that creates. Yeah. I'm pretty sure all of you have run into issues that you order some prototype and the prototype is beautiful. It's wonderful. Your people go spend a lot of money, go to the supplier side. They make sure that the product is produced the way it should be. And then they find out that it was shipped in a packaging that was not suitable for shipping and it arrives all banged up and damaged. Yeah. And then everybody scratched his hand and said, how could it be? Yeah. So that is behind it, that we say, is my storage, is my packaging, is my transportation suitable? Yeah. Also, what's overlooked many, many times, I don't know most of you, and I don't know the background of the companies that you work for, but if you have locations in different parts of the world, yeah, you will know that having a location in, let's say, northern Germany that's fairly cold and wet, yeah, your climatic conditions are completely different than when you have a manufacturing location, let's say, in Mexico or in somewhere in Brazil or so, yeah, where you are dealing with a tropical climate, with high humidity, with and so on, yeah. So you cannot have the same transportation, the same packaging if your supplier or sub-supplier is, again, using the example Northern Germany, if they are 5 kilometers away and they deliver something, or if you have to ship parts by air freight or by sea freight. Yeah. So these are things that you have to take into consideration. Yeah. And then you also have to make sure that when you do have deviations to control plan, deviations happen, life happens, yeah. And the issue is not so much, well, of course, one of the issues when you have deviations, when you have defects, yeah, one of the first questions that you ask is, why did it happen, yeah. And that is the right question. You don't ask who caused it, but why did it happen, yeah. And the finding, why did it happen, to determine the root cause and then go into corrective actions, that is also one of the aspects of the control plan. And then, as I mentioned, there is a whole series of appendices to the control plan. And somewhere in the control, in the APQP, you will find that it says that the APQP, it's a framework and guideline. Yeah. So by the very definition of these two words, framework and guideline, it does not mean that you get a recipe like when you bake a cake and you have to exactly follow the recipe. Yeah. That is not what APQP is about. APQP gives you a recipe as a guideline to say, hey, here are my questionnaires, which will help you to walk your process, which will help you to do your planning. Yeah? Here are the aspects that you have to follow. Here are the requirements that you have to follow. Yeah. But how do you exactly do that? Yeah. This is left to each organization to adjust these to A, size of an organization, B, to a specific product, C, to specific requirements of the product, to specific requirements of the customer, to specific. There is a lot let's say, flexibility that it's left to each company to say, hey, you can adjust these as needed. Yeah. But not but. I hate the word but. And when you need the help, when you don't know exactly where to help, where to start, here are all the different questionnaires, and here are all the different tools in our toolbox that will help you with that. Yeah. And so the appendices, which are part of the APQP manual, is the product quality planning checklist. And there is, like I say, a multitude of checklists which are already included there. Then there is description and also guideline how to use these gated management. Gated management sounds horrible, but this is the quality gates, which I defined before. Yeah, so that you go from phase A to phase B to phase C. Yeah, and at each quality gates there are certain requirements and certain questions that you have to ask ourselves: is my project on track? Am I doing the right things? Do I have the right results? Yeah. And you can imagine that when you go from a concept phase into development phase, you have a whole different set of questions than when you go into the series production. Yeah, and this is where this is meant what is this gated management. So there is like a guideline to these different gates. Then the analytical techniques, what to help you analyze where you are and what are the further actions. Then there is a team feasibility commitment. Then the quality planning, summary, and approval. And again, to each one of these, there is additional information then that follows. Yeah. Then there are certain reference materials that you say, hey, we cannot describe everything here in that manual, but here's the reference material that helps you to get additional information if and when needed. Yeah. Then definition of glossary and the index. So in summary, the APQP process, the IAG process, provides a structured approach. And again, here the emphasis is on structure to ensure successful new product launches by creating product quality plans that support development of product and services. So this is more or less slightly different verbiage from the manual itself. Yeah. So in a summary, it's a structured approach that provides the framework. Then, and this is really one thing is to say, yes, we have the structure, we have the framework, we have the thing, but how do we do that? So this is achieved by providing the quality tools. So it's the same thing as when a plumber comes to your house and needs to fix your boiler that's leaking. So they have a toolbox with tools. Here you have also a toolbox with tools that help you with this developing and monitoring the each step of the process. And then only and only if you consistently, or again in German it's called consequently, consequent, yeah. If you consistently apply the quality tools, that will really help you to establish efficient and capable processes. And again, as I said in the beginning, if you have efficient and capable process, you will have high probability that the products which come out of this process are high quality products. And if you have high quality products, if you have high quality of the services, that will also mean you will have high level of customer satisfaction. Yeah. And to all of these topics, it's kind of difficult to pack all the information here. So there is a lot of further information and in-depth training. It's also available from TopQM-Systems. So, any questions?
Thank you, Milo, for the depth or the deep dive into APQP and Control Plan. And we already got a few questions during the presentation. So if I may begin reading maybe the first question, if you know anything of harmonization of APQP and MLA or something like that.
I personally, I am not. I have heard. Maybe Andreas or Andre know
Mhm.
more about it. I have heard that there are some activities going, but I personally do not have that information.
Yes, so me also not yet. So what I know is they are doing the MSA and VDA 5. And like you said, I think you mentioned the SPC topic of VDA SPC. This is the current working groups. What are they working on the harmonization topic? But I have also not heard anything yet from AIAG or VDA about harmonization of APQP or MLA or something like that.
I honestly, my personal opinion is I would not be surprised if there are some activities already going on. Yeah, because again, with the global manufacturing network of both OEMs and the tier suppliers. Yeah, it's
Mhm.
difficult to deal on one side with VDA, on one side with AIG, but things are almost the same, but not quite. Yeah, so
Right, right, right.
creates a lot. So I would assume that there are some activities going on, but again, without repeating what we said, don't know. Yeah.
Um, okay, yeah, thank you on this. We had one question. I'm not sure if this maybe is too deep, or maybe we can take some more time to get that answered correctly. But the question was, how can special characteristics are taken care in heat treatment if it is defined as a hardness or case depth? So I think this is a very good technical question.
Mhm.
So I think if there's no immediate response to it, we can have a closer look at it and provide a more profound answer to it if necessary.
Yeah.
I don't know
I,
if you have anything to.
Yeah, I would say simply again out of the real life experience. Yeah, a characteristics that's defined for heat treatment is not anything different than characteristic that is defined for turning or for grinding. Yeah, so you define what is it that you need as far as the characteristic. So you define, let's say, in this case, you would define hardness. Yeah, and you put on a drawing. Um, Again, ideally, you put on a drawing a section where you say, I want to have the hardness tested in this exact area of my product. Yeah, because you cannot say, particularly if you have an geometry which is not kind of, let's say, symmetric or, yeah, then it's, you put the part through the hardening process, but not every part of the component is hardened the same. Yeah, it doesn't have the same hardness. So two things are important. Number one, that on the drawing you define exactly the area where do you need that hardness. Number two, you define what hardness you need. Yeah, meaning what is the value and what is the hardness methodology that you want to use. Hardness, I mean, Brinell, Vickers, whatever. Yeah. And then this characteristic is then carried, so you define it on the drawing that you provide, on the specification that you provide to the organization. And then the organization carries that specification through FMEA, estimating, okay, what can go wrong, blah, 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 identifies it in the FMEA, special characteristic. Then it goes, some companies have a specific important characteristic list. I know Bosch does because I worked with them. Yeah, other companies, I'm not so sure how they handle it internally. Yeah, and then it has to also be identified in the control plan as the specific characteristic, and it has to be made sure that it's checked on a regular base with the frequency defined in a, let's say, in a cross work with the FMEA and control plan. This is where the FMEA becomes one of the central tools, because FMEA, you define the probability of occurrence, you define, or not define, but you estimate probability of occurrence, you define the probability of detection, yeah. And with the probability of detection, you define a detection method. And this detection method has to be then transferred to the control plan. And the probability of occurrence gives you the frequency. How often do you have to check that thing that you have defined in a control plan? That's again why control plan is the central document. Yeah. I don't know if that answered the question or if the question was meant in a different way.
maybe then, yes, we can maybe get a response on this. But another good question was about APQP, because about APQP in series phase after SOP, because the question was because it seems more like of a project methodology, project management methodology, or how is APQP needed in series production phase?
Okay, so the best ways to answer that, yeah, is you look on the slide, which is here, yeah. You go into the quality gate, yeah. So which is then introduction into series production, yeah. And different companies have different philosophies, but normally all these APQP is considered as a project, yeah. So once you are into series production and you have gone through your QG5 to your quality gate 5, which is typically 3 to 6 months after the series after the introduction into series, yeah, then typically the project team gets dissolved, yeah. So that means at this point in time, the planning, as you know, the P in APQP is product quality planning. Yeah. So this is where the planning stops and the series production then takes over. And in series production, you have then processes which also IATF kind of drives, that you say you have to have a change management system. You have to have your Q, some people call it the AD system, some people call it quality deficiency, and so on. Yeah. So strictly speaking, in my personal opinion, APQP stops with the QG5 once you go into full series production.
Thank you, and for this explanation. And I believe we have also another bit of a bigger topic and discussion going on. But first of all, a smaller question. Is there any general or global checklist for APQP?
Yes, there are multiple checklists, and I have an example here. Okay, just a second. Okay, so let me give you an example of the checklists. So when you go into checklist, you will find 10, respectively 11 different checklists, which are part of the APQP manual. Yeah. So again, now I'm not really sure what it's meant with the word global checklist. Yeah.
Mm-hmm.
So there are these checklists which are defined. So one is the risk factors checklist. So this is the overviews of the APQP chapters. Then you have the checklist for the design FMEA. Then you have checklist for the design information. Then you have checklist for the new equipment, tooling, and test equipment, and so on, without reading any of these. But when you see, so pretty much for every step you have a different checklist. And then just as an example again, yeah. So this is just a plain screenshot out of the APQP manual. Yeah. And you see, this is where you have, and I apologize for the quality. It's a kind of bad, bad quality. But this is where you get really very detailed checklist for each chapter you are looking for. So when you say, do I have a global one? If it means, do I have one that covers all that? Yeah. The answer is no. You have checklists that you can use for individual phases, for individual topics that you have.
Milo, here's
Yeah.
Andreas. I have, I put it checklist overview into the chat.
Okay.
A screenshot of the
This
chat.
is the checklist you get as downloadable content if you purchase the standard, right?
Correct.
Yeah. And global, it means, yeah, it's global valid for for the all suppliers globally, and there is no one checklist,
Right.
like Milo said.
Mhm.
Okay.
And that's why I'm always careful to answer questions like that, because global can mean geographically, can mean contextual.
But I think the context was more towards the general accepted checklists. But I think that was answered. I wanted to lead to a discussion that came up, or initial question that was, and I would just read it out. It was that, I mean, Matthias, if you would like, you can for sure ask your own questions again if you would like. Otherwise, I would go ahead and just read it out, what you wrote in the chat. And this is that the question was, current VDA 6.3 process audits are checking the intent of the existing control plan on the basis of IATF, IATF clause 851.1, control plan, Anhang R, attachment A. Do you know or think that the requirements from IATF and AIAG will be harmonized and maybe even made be mandatory to check in any or for any VDA 6.3 audits?
That's an interesting
Good question.
Where we could really spend a whole evening discuss about it. Yeah. So if you look, okay, let me start the other way around. Yeah. So the BDA audit and the IATF audit, they have different focus. Yeah. While they have a lot of similarities, they are different. So I got, when I was in charge of the VDA auditing, I was asked a lot, how is that different from IATF? Yeah, we had suppliers asking, well, I get IATF audits all the time. Why are you guys coming and do the VDA audit on top? Yeah. And to be honest, the best way I found to be explained is having a car. Yeah. So the IATF, it's like your inspection. They check, is the car okay? Does it work? Does it do the lights work and so on? Yeah. Do you have the systems in place? Yeah. The VDA is the driving test for the driver to say, does the driver know how to use the car, which is then inspected by somebody else? Yeah. So for me, I do not think, again, it's my personal opinion, yeah, but I do not think that VDA 6.3 and IATF will be harmonized ever, because they have different focus and they have a different, let's say, lifetime, yeah, because VDA 6.3, it's usually focus on a certain part number produced at a certain manufacturer, usually sub-supplier. Not always, but let's say usually. At least that's how we handled it. So I do not think that there will be a harmonization between those two for those reasons.
Milo, one point from me. Last point to this question. A control plan or from IATF, it's exactly defined in the Appendix A. And VDA 6.3, they talk only about control plan, not more. And I think you could harmonize, or you could create on your own the official, valid, globally APQP control plan, and then you are fine.
Could be, yeah.
I apologize for not having made a function able to raise your question. I'm sorry about that, but Matthias, please go ahead.
Yeah, sorry. No, you're absolutely right. So I don't want to ask about harmonization about IATF and AIAG and VDA. It's more about the requirement set in the IATF, how a control plan should look like. And this is something we are referring in the VDA 6.3 audits. I would also like to harmonize the things from the AIAG control plan within the VDA 6.3 audits as other ideas, as the AIAG approach for the FMEA was also overtaken by VDA. I think it's a very good idea. And this was more the basic of my question.
Okay, there's definitely, let's say, elements that can be harmonized. If they can be make into one, I doubt it.
Yeah,
But yeah, definitely elements, absolutely. Yeah.
I agree. Yeah, good point.
One other question I want to raise, there was a question that asking, does special characteristics mean the same than significant characteristics?
That's what I mentioned during the presentation. Different people call it different ways. Generally, yes. Yeah. Now, sometimes they might be very narrow definition of some. Why does somebody call it special? Why does somebody call it critical? Yeah. But for me personally, over years, I found this is one and the same.
Okay. So another question that came up was, what are the best practices in handling of APQP in between customer and supplier for certain projects?
Okay, I'm not sure I understand the question. I'm sorry. So what was the question again?
So maybe that it can be.
Can whoever ask it, can it clarify what it's meant? That the best practices. You mean what are the best practices out of the practical application, or
maybe just the handling of APQP in between towards your customer and the supply?
okay, one of the best practices I found, yeah, as trivial as it sounds, yeah, is to have the right people talk to right people. Yeah. So what I mean by that is when somebody says APQP, do you understand what it is? Everybody around the table nods and say, yes, I know what it's APQP. Yeah. But different people understand different things. So when I say the right people need to talk to right people, that means part of the APQP is the project planning. So that means the project planning aspects need to be defined between the project management people at the supplier and the project management people at the customer. And there is very, very important, this was kind of mentioned briefly, the feasibility commitment. Yeah. So the customer has certain requirements and the supplier has to commit that they will meet those requirements in writing. Yeah. Because latest when it comes to PPAP, if there are still some open points, there will not be a full PPAP, there will be more likely a concession because there is something unclear. Yeah. So that's what I mean. Quality. The project people need to talk to project people. Quality people need to talk to quality people. So when we're talking MSA, when we're talking the machine capability, when we're talking capability of the measurement equipment, when we're talking process capability, yeah, this is usually when we don't need the project management people. We need the experts. We need the people who can handle the measurement, who can handle the measurement methodology, that they talk to each other. So this is for me another good practice, again, that I have the experts on a topic on one side at the supplier talking to the expert on the same topic at the customer. Yeah. So these are the two biggest lessons learned and the two biggest good practices I can think of. Yeah.
Thank you for sharing that. And
yeah, just I would like to, because I couldn't handle to unmute myself. It was question raised by me.
Sure.
I think you felt exactly what was my question behind, and it was really how to make the APQP more efficient in between both partners, customer and supplier. And does it is also could improve if we have more frequent on-site APQPs done? I mean, customer visiting supplier and checking on-site with relevant people the process, the progress.
Yes, absolutely. No ifs and buts. Yeah. And during those visits, really, please make sure to bring your engineering people, your development people. Because I have seen too often that the development people, they develop a product without ever have seen how this product is actually manufactured and measured. So that's also one very important aspect, to have the design engineering people also be on site at the supplier to check how does the supplier measure the part that I have put my measurement specification on the drawing. Yeah. You're absolutely correct. You cannot overemphasize the face-to-face contact. Yeah. Did that answer your question?
Thank you for this answer. And in relation of making the right connection with the right people, the right departments, sometimes it would be maybe not that easy because not all people are available. Not all people can match to meet and speak in the same time. Let's say, especially when we speak about a big distance and arranging conference calls in between. Sometimes the language barrier could be a problem, but that's let's say that's the life.
Life happens. And one point also, which is extremely important in our global world, you touched on one point across talking to each other across time zones. Yeah. And also one lessons learned that I have learned, I worked for a big company, yeah, where we have one representative of the supplier quality, one representative of customer quality, one representative of commercial purchasing, one representative of project management, one representative of, yeah. Then you go to a small company, yeah, where two people handle all that, yeah. And the smaller the company, sometimes as they call it in English, mom and pop shop, yeah, you might have 3 people handling when Bosch comes with 10 different people. So that's also one important factor, is to be aware of these differences in sizes of the company. Yeah. Again, particularly when we want the right people talking to the right people. Yeah. And to understand that not everybody has the full extent of a big company if you're talking a small company. Yeah. So that's what is important to understand, that sometimes I talk to one person and that one person covers everything and we get frustrated. Why do I not have a quality manager? Why? Because they might not have a quality manager. Yeah. So that's also one lessons learned that I learned over years. Yeah. Learn a little bit about your company and why do they work the way they do. Yeah.
Is there, let's say, a preferred person who's supposed to have the leading role, let's say, at supplier side to handle the APQP? Should it be a quality? Should it be just a project manager? Should it be someone from sales? Or it doesn't matter as long as he's competent.
Whoever has, you mentioned the last word, whoever is competent, whoever has the hat on of project management, because the project management encompasses all of these activities, yeah, which does not mean that the project manager does every single one of the work packages which are done, but project manager has the responsibility that these work packages are done, but by people who are competent to do them, yeah. So if you say the one person, for me, I'm always looking who is the project manager, who is the voice of the supplier when I'm the customer. Yeah, it has to be clear, who am I talking to? Because the worst thing that can happen is if we have multiple communication channels, yeah, who do not talk to each other. Somehow these different communication channels, they have to be channeled through a focus, let's call it either focus person or focus team. Yeah. And so one of the good lessons learned that we had was also to establish regular meetings with the regular frequency, yeah, where we have then, it can be multifunctional team, SE teams, yeah, the simultaneous engineering teams, yeah. If they work well, they are one of the best things which I've seen. If they don't work well, they do more damage than good, yeah. So again, focus communication is the key. Having the right people talking about the right topic is the key, yeah. And having the people, let's say, document agreements, because if they are not documented well, just a simple thing like an open point list. Some people call it OPL, some people call it LPO, list of open points, some people call it LOP, yeah. Document what you discuss in your meeting so that you can pull it up next time. Yeah. For me, that's one of the simplest but most effective tools: communication and documentation.
Thank you.
Thank you. Thank you also, Milo, for the explanation. And I think we can fit, if it's okay for you, 2 more questions in that came in. Talking about teams in general. So in the previous version, they talked about core team in the section of in the template of the control plan. And apparently in the first edition now, in the template of the control plan, this naming of the core team had been removed. And the question was, do you know if there's any reason why? Of course, any company can decide how to do it, but apparently in the template, it had been removed to name a cross-functional team. Do you know anything about this, why it could had happened?
Since I was not part of it, I don't know what the thinking was. I can only suspect, yeah, it's my personal assumption that it's more in a direction of cross-functional teams than core teams, yeah. But no, I don't know why. The problem with core teams is that it's that it's sometimes depending on the person, yeah. And if that person drops away, then it's. But no, I don't know. This is just me thinking and talking. The short, no, I don't know why it was removed. Yeah.
Okay, thank you for this. One more question we had, and maybe this is the final question then for today, is that you said, Milo, during the presentation that SPC is not mandatory for all critical characteristics.
Correct.
But how we can then explain this against an IATF requirements to prove capability and monitor them by the statistical tools?
Okay, so capability is more than SPC. Yeah, you have multiple ways to prove capability, and it's also this is also usually defined by the design engineer. When do I need capability? So sometimes you will see on the drawing from customer to the supplier that the capability needs to be proven at the PPAP time when I release the product. Yeah. So when you prove the capability there, it's okay. Yeah. The second way to prove the capability is to collect the data over a certain period of time, let's say a week, a month, or whatever. Yeah. And then you calculate the capability and you say that the capability is okay or not. SPC now specifically, yeah, you define SPC, it's a whole process where you define what are they called? Eingriffsgrenzen auf Deutsch, the limit, the control limits. Yeah. And the control limits, they are less than the tolerance which is allowed for that characteristic. Yeah. And the SPC, the whole charm of the SPC is that you are checking, am I close or am I in danger of exceeding my control limits? And I have an immediate loop back when I adjust my tools, my process, whatever, to go back into within the control limits. Yeah. So SPC is needed then when I need a very, very close control loop of my characteristics. Yeah. So process capable does not mean I have to monitor it all the time. That depends on the process. Yeah.
Milo, I have also a conclusion about that. It is not necessary in any cases to have a capability study or evidence based on a statistical calculation. It's also possible to have attributive go, no go.
Correct.
If you check, for example, 30 parts, and they are all in the limits, go and no go may be a gauge, and then it's also a capability study.
Correct. Yeah, it's not contradiction to what I said. It really depends.
Yeah.
What is the characteristic? What is the geometry? What is so? There are several factors that say what is it? Yeah. For example, just again simple example. I like to talk in simple. Yeah. When you have a 0.5 millimeter sheet metal, yeah, and you stamp a hole with the stamping press, yeah.
Yeah.
When you have a punch tool and chances are that hole number 1 and hole 10,000, number 10,000, that there will be hardly any deviation. Yeah. But if you have, and so there you have a high process capability and you don't have to monitor it all the time. Yeah. But when you drill a hole in a piece of, let's say, in a steel block, yeah, with a drill, where the drill wears out pretty quickly and you have probably to replace your drill every 400 pieces, yeah, there it probably makes sense to, where you have high tear and wear, yeah, there it makes sense to check that characteristic quite frequently and make sure that it doesn't drift, yeah. In that case, SPC might make sense. In a case of stamping the hole in a thin sheet of metal, it does not make sense. Yeah, this is where your go no go comes into game, for example. Yeah.
Yeah.
So did that answer the question, or did we miss the intent of the question?
Yeah, maybe it was. It led to a follow-up question on this. That the question was, if there is no defined critical characteristics, how SPC needs to be handled then? Supplier is still responsible to choose a random characteristic by himself, or how would that be handled if no critical characteristics is given down by the customer, I believe is the question.
So if customer does not define any critical characteristics, yeah, so that means that all the characteristics on the drawing, the customer does not have any special requirements for that. Yeah. So this is where what we discussed just a couple points ago, where this discussion between supplier and customer comes into game. Yeah. That the supplier can ask, dear customer, are you really sure that none of these characteristics is really critical for you? And if that's the case, yeah, then why would the supplier put anything in place that would cost him money, but does not bring any benefit to the customer or to the supplier for that case? Yeah. So the short answer is, if there are no special requirements, yeah, the supplier is under no obligation to put anything in place. They can put things in place, yeah. I mean, it's always left to the supplier, but if there are no special and critical characteristics, no measures have to be implemented.
So in order to prove or measure their own capability then for this production, they can choose the characteristics they seem appropriate, right?
Absolutely. Yes.
Yes. And it's based on their own FMEA.
FMEA, on their own experience, on their own. Absolutely. Yeah. I mean, the supplier is under obligation to do their own FMEA, as Andreas just mentioned. Yeah. So no customer requirement does not mean that the supplier can just wave the hand and say, okay, we don't care about it. Yeah. They still have to deliver the product and prove that the product meets the customer spec. Yeah. So lack of or not defining critical characteristics simply means there is nothing that the customer deems to be especially critical. But it does not mean now I can produce parts out of tolerance and so on. Yeah. The supplier still needs produce within the tolerance. Yeah.
Thank you, Milo, very much for answering all of those questions, and also to you all. Thank you very much for listening to the presentation and raising the questions and asking the questions. So I think we are very right on time. And yeah, it just leaves me to say thank you, Milo, very much for talking about APQP and Control Plan, about the details on it, about the Q&A session. And thank you very much, all of you, for participating. And just as a hint, the last session will be, or the almost last session will be at 3 p.m. about the AIAG CQI special processes. And then we will have a closing. And yeah, thank you again. Thank you very much, Milo.
Okay,
and
thank you guys. It was a pleasure. Great questions. I really appreciate good participation. So thank you very much from my side. And thank you for the opportunity to present, Andre and Andreas.
Thank you.
Right.
Thank you, Milo. And yeah, I wish all of you a good rest of the day, and maybe and hopefully see you at 3 p.m. Thank you.
Okay. Bye-bye.
Bye.
Bye-bye.
Bye, everyone.